Hello everyone, just like to start this little presentation, so off we go. Hopefully this will work, there we go. So just a little bit about me first. My name's Malcolm Cowan, I'm the director of 2020 Post, just checking it's all working. I've worked for the BBC for 26 years with a background in post-production editing. Over the years I slowly sort of migrated into the world of setting up large post-production events for huge sporting events. So that's mainly my background from the last sort of 10 years or so. I basically just delivered the Olympics, then left the BBC for various reasons, mainly to do with Salford. So basically, I'm going to chat you through the whole Olympics and how it all worked, what the sort of how we sort of set it up, the planning, etc., etc. Now, obviously, I didn't deliver this on my own. There was a big team of people involved in it all, but we had a core team of 6 people working on this for 3 years, dealing with the sort of studio side, the post-production side, the outside broadcast side. So, you know, this by no means is all my own work. So just to let you know, there's a lot more people behind this than just me. I'm going to sort of slowly go through this. There's quite a lot to take in. There will be a sort of period in the middle where I'll stop to take some questions in case you want to pick anything up. And then there'll be time at the end for question and answers again. So I'll just sort of pick up any questions there. So we'll start off with a little bit of a flavour of the Olympics, just to remind you what it was about.
Good evening, Swan.
Good evening.
Okay, so before we get into the nitty-gritty about how the post side of things worked, I'll give you sort of some figures to give you a scale of the Olympics. So on the left-hand side of the screen there, that's sort of what the Olympics was all about. If you broke it down into sports, gold medals, etc., how many fields of play there were, how many venues there were. And on the right is kind of how that translates into the world of broadcasting the Olympics, whatever form you're doing. There were a huge number of feeds coming into the IBC. And a huge number of commentary positions, lots and lots of accredited right to hold broadcasters. So you can see the scale of it was pretty huge, and was the biggest Olympics to date. So let's try and sort of understand the BBC ambition for the Olympics. Obviously, we're on home turf, so the mantra from the BBC was every session, every sport, every day. So there's a strong drive to engage the public as much as possible across all platforms. So we had the sort of terrestrial channels dealing with BBC, HD. We also had a 3D offering. But we also had digital Olympics dealing with things like interactive. We had the super high vision feeds, went to a couple of places in the UK, as well as all the radio that was going on as well. So as you can see, as far as the BBC was concerned, that was a huge amount of its output across multiple channels. So how did it all work? So to try and understand how this sort of fits together, you need to understand the organisation of the whole event. On top of everything is LOCOG. So they are the London Organising Committee of the Olympic Games. They were responsible for building the venues, running the venues. They were responsible for sorting out things from printers to hire cars. They were the sort of organising committee. They were sort of doing the nitty-gritty of getting the Olympics up and running. Underneath them, or in parallel with them, we had OBS, who were the Olympic Broadcasting Services. Now, they basically formed their own company in the UK called OBSL to satisfy the requirements for the Olympics. OBS is quite a small outfit between Olympics, based in Madrid. During the Olympics and the run-up to the Olympics, they increase in size massively. They employ lots of third parties, outside broadcast companies, etc., etc. So during the Olympics, OBS was huge. And then obviously there's the BBC. Now the BBC is one of the rights-holding broadcasters. So the BBC pays for its rights, it gets access to all the feeds, and pays for all the additional services provided by OBS and LOCOG as required. That gives you a sort of flavour of the organisation. And let's just talk a little bit more about OBS. They were created in 2001, so they work directly to the IOC for the provision of the TV side of things, the radio side of things. They design, build and install the whole IBC setup. Now, the IBC for the Olympics in 2012 was huge. It's just north of here in Stratford, and it's got a certain amount of legacy built into it, so that building will be used after the Olympics for other projects. Now, in the past, there's been a lot of criticism of the fact the legacy side of things isn't taken care of, and a lot of buildings are effectively mothballed and never used again. This was definitely a strong drive from LOCOG that this would not happen. So you will find that in the future, the IBC building will be put to good use. As well as providing all the services in the IBC, they provide a lot of the venue feeds, they work out all the technical infrastructure, and effectively act as the input and the output for the whole of the Olympics. So I'll start this one in terms of so you understand what's going on across the UK, but we'll slowly drill down into London and into the IBC. So the BBC in the UK, we had a lot of venues. Obviously, the Olympics was across the whole of the UK, but the core operation was in the Olympic Park. We had feeds from various venues across the UK. So if we now look in London and drill down even further, you can see sort of across the London real estate, there was an awful lot of venues spread across from sort of, oh, my laptop's just crashed. Excellent. Thank you. Right, you still seeing what I'm seeing? Yes, excellent. We had from West London to East London, a huge number of venues to deal with. All these ended up back in the IBC. One of the venues is here, Excel Centre. We had, because of the number of events taking place in this building, we had a switching centre that controlled everything, but that was all done remotely. So in the IBC, we could choose any particular venue within this building to switch the feeds back into the IBC. So let's now zoom in even further and talk about the Olympic Park. So just north of here, up at Stratford, is where the Olympic Park is. It's a very large venue. As you can see, there's an awful lot on there. Our main base, obviously, was in the IBC, but we also had our studio on site, which serviced all the channels, BBC One, BBC Three, worked for news, worked for radio, etc., etc. We also had an operation at the Olympic Stadium, where we had a large presentation presence, an outside broadcast setup, so we could take care of all the requirements around the Olympic Stadium. Excuse me a minute, this is just... we also had presentation positions at the swimming and the velodrome. Now, let's look at how many circuits we had coming into the building. So in addition to the 46 feeds provided by the host broadcaster, we add on all our other circuits. So we had over 50 coming in as well. So when you add all those together, there's a huge number of feeds coming into the building. We also had feeds coming in from news. We also had data connections to various parts of the country, including Weymouth and Salford. And that all looks fine, and it was quite complicated in audio and video terms. When you add commentary and comms on top of that, it's incredibly complicated. We also had 24 PSC crews out and about shooting stuff on SBS cards, as well as news crews out shooting stuff on SBS cards. All of that came back to the IBC. So the IBC was genuinely the hub of the entire operation. So it was quite a big piece of work to manage all of that. So I'll take some questions if there are any at this point in time. No, I'll counter on then. Right, so let's talk about the IBC operation. The BBC had space within the IBC. The IBC is a huge building. And sort of we had a sort of area on the ground floor. This is the biggest area the BBC had ever had for games like this. So we had this much space within the IBC. It was about a third, two-thirds bigger than what we had for Beijing. And we had roughly 500 staff working across the Olympic Park. But to put it into context, that's how much space NBC had. So they were massive in comparison to us. They had 2,700 staff working on the Olympics. And they had their own Starbucks as well, which is fun. So let's drill down even further and look into the layout of the IBC. So this is the floor plan for the BBC. I'll just go through briefly where the different areas are within the BBC, and then we'll sort of go into the post-production side of things. So this was the main office, serviced all the requirements for all the production staff, all the IT, they had viewing feeds, they could pick up channels and watch stuff that was going out. This was the radio office. They had their own radio studios, all their office, all their IT in this area. News occupied this area. They had connectivity to our systems. We supported 4 of the edit clients on their real estate, and they had their own switching operation as well. This area was graphics. Obviously, there's a huge amount of graphics added to the output. And also this area serviced the requirements we had in post-production to add graphics to all our items as we went. I'll explain a little bit more about that later on. Now, these areas are the sort of production galleries. Because we were effectively servicing 2 channels simultaneously most of the day, and occasionally supporting up to 3 channels, we had lots of galleries to do that. The whole thing was incredibly complex because of the number of feeds coming in, the number of feeds going out. We had to deal with the whole sort of managing of all of that. So this is Central Technical Area 1, which is where the broadcast kit was. That's the post-production area, which I'll drill into later and talk about. But quite importantly, the bit in the middle in red is what we call the Broadcast Operations Center. This is where everything got packaged up. If you are sitting at your edit suite and you want to actually pick something up, you don't want to have to pick up the vision, find the audio, find the comms, all the rest of it. The philosophy we adopted quite early on with the Olympics is that we would create packages. The BOC was responsible for creating the packages. So if you had a feed coming in, you wouldn't look for the vision for the mountain biking, you wouldn't look for the audio for the mountain biking, you wouldn't look for the comms for the mountain biking. We had a control system called BNCS, which managed everything. So the BOC would package everything up. You would look on a touch screen and you would find a button called mountain biking. You would select that. That would then give you everything you could possibly want for that feed. It automatically gave you all the communications, it gave you all the audio, gave you all the video. And all your comms panels would light up, so you'd only have to put things on buttons. They would just appear on the buttons in front of you. So that made our lives a hell of a lot easier compared to previous events where everything was done with matrix hardware panels, and we sat there and did it all manually. It lightened the load incredibly, and we could not have done it without that philosophy being in place. Tied into that was how the audio worked. So we had a lot of audio coming in. There was, on live transmissions, we would work 5.1. For edited items, it would be stereo. The BOC was responsible for making sure the audio appeared in the right place on all the feeds. And then depending on what we were doing with that feed, it would either go live and we would transmit 5.1, or if it was going to post-production, we would still maintain all the 5.1 where possible and keep it on our systems. However, at point of transmission for edited content, it would generally be stereo. I'll talk a little bit more about that in a second. Okay, so let's now talk about the post-production side of all of that. So drilling down even further, we're now looking at the floor plan for post-production. So if we look at these different areas, I'll just canter through what they are. So at the bottom there, we've got edit suites. We had 8 edit suites. These were actual suites, rooms with walls, ceilings, the whole lot. You could monitor your audio on speakers in there. So you had quite a nice environment in which to do your editing. Out in the area had what's edit desks. So as far as kit went, they were identical. They all had the same hardware, all had the same software. But the edit desks, they were a condensed version. You could get a lot more edit desks in a much smaller area. All the monitoring was done on headphones in these areas. Obviously, if everyone had speakers turned on, it would be a cacophony. So there's a different philosophy of working at edit desks as opposed to edit suites in terms of how we generated the audio, which I'll explain in a second. But it did mean that we could, using the edit desks, we use those mainly for fast turnaround workflows. So content would arrive, go through the systems. We would make that content available at the edit desks. They could then quickly turn stuff around, add graphics, and then send it to transmission, all completely file-based. Down at the bottom corner there, we have our 3D operation. We did a small amount of 3D. It was advertised as a 3D transmission, but basically we were taking the host's 3D feed, packaging it up so that it sort of conformed to our requirements, because there was quite a lot of stuff that came in that was slightly duff, which we then turned into a nice 3D highlights package for transmission late in the evening after BBC One HD had gone off air. Up at the top is ingest. Now, that area was vital to us. We had the ability to record 32 things simultaneously, 32 ingest positions, as well as handling all the cards that came in from the crews, ad hoc stuff coming in on tape, funny formats, discs, whatever. Ingest was quite core to the operation, obviously, and this is the area at the top of the picture. Down at the bottom, we had our transmission replay area. Because we had to support so many channels, we effectively had 3 transmission replay LSMs with desks. The philosophy behind this was that they would each have 2 LSM operators and a producer. The producer would drive the whole transmission side of things, working with whatever gallery they were working with on air with. So 3 desks work with 3 galleries to provide the output. All the content, whether it be from an edit suite, an edit desk, straight live content coming through the system, all ended up available to those people at the TX positions. So if we did just turn an event round, it wasn't edited, we could pick it up off the system. We still had all 16 channels of audio. We could send it through to the gallery. They could pick up the 5.1 and transmit as 5.1. So it's only edited packages that were never in 5.1. In the middle is the sort of coordination area and support. So this is the area I spent most of my time. This is where we kind of made sure everything happened in the right way. We looked after staff, we scheduled bookings, we made sure that all the people were in the right place at the right time, handled any issues, and I had a team of 3 people helping me support the whole system from various manufacturers. And to be honest with you, couldn't be done without their help. CTA2, so we had our own separate SEC technical area. This was because all the kit and post world tends to be noisy, tends to get hot, and tends to generate a lot of heat. So the decision was made quite early on. We would separate it away from the broadcast kit so that we could manage that in isolation. And in the middle, we have a sort of logging and media management position. So in the center of the picture is where we did a limited amount of logging, generally of PSC content that came in through the building. And that's where we did the media management. So anything was decided to be kept for archive or deleted off the system, that's the area that would take place in. There was a huge logging operation in Salford. Salford took 24 streams going north. They took those into their area and they logged those. We had a data feed and connectivity between our operation down in the IBC and the BBC operation in Salford. We basically could mirror our databases. So any content that was logged in Salford, we could get those logs, apply them to our content down in the IBC, so anything could be found quite quickly. If nothing was ever logged in Salford, we also had this thing called the broadcast data feed. So the host provided a BDF. That BDF had huge amounts of data within it, but it also included basic logging data. So we had a process in Salford. If a feed was not being logged, the BDF metadata was applied to that feed. So we had basic information like when the event started, when the gun went off, when the finish of the event was, etc., etc. Also information about the athletes that were involved in that event. So even if nothing was logged, we still had enough information to find content on the system. So it's probably difficult to see on this diagram. I couldn't really find a way of getting all this on one slide, but this is a sort of very helicopter view of the whole system. So on the left-hand side is basically vision coming in, video circuits coming in. We also have our connectivity up to Salford on the bottom left there, which is that sort of bluey coloured box, and our data connectivity to places like sailing and graphics. So 32 ingest channels, content hits the system, the servers start recording. We have various processes take place after that. Because of the nature of the EVS servers, they're always recording. So if someone comes running in with their hair on fire and goes, I meant to record that feed, as long as it was on the input to one of our servers, it would have still been there. And from a resilience perspective, we designed the size of the system such that there was enough disk space on those servers that we had about 24 hours worth of content available to us. So if someone came in and said, that thing I forgot to record yesterday afternoon, is it still on the system? 90% of the time, yes, we still had it. We'd effectively spool back through the record train and we'd still be able to get hold of it, which is great from a resilience perspective because if anything went bang, we still had the content available on those servers. That content then got moved onto the central blue block, which was called our work in progress. It's basically a large Omni and media grid. It arrived on that grid in two flavors. It arrived in our house codec, which was DNX 120, and also in a proxy form. The ability to have proxy media and high-res content on the same system gave us a huge number of options. We meant we could deploy a desktop viewing setup called IP Browse. Now, this is the same process they use up in Salford for the BBC, up there. And basically, it means that you can see any of the content in a low-resolution form on any kind of IT desktop infrastructure. It looks a bit like a web browser. It's not, but it looks like it. You can actually then look at the content on the grid. And you can also then do things like make decisions about what you want to do with that content. It's all driven by user rights, but if you say you have the right rights, you could put together a compilation of shots and effectively send that as an EDL through to an edit, or you could send it directly to transmission. You could do anything you want. All you're moving is the metadata, all you're affecting is the metadata. The high-res content resides on the media grid in the middle and then gets moved to the appropriate place depending on what you've decided to do with IP Browse. This meant we didn't have to have producers sitting in edit suites viewing things. It meant senior producers could watch the output, could we record stuff back into the grid. You could see anything you wanted at your desktop. It meant that the post-production area wasn't sort of deluged with people wanting to see things. They could sit at their desktops and look at them. It meant we had a huge amount of flexibility in terms of remote viewing as well. Salford could also see that content. Salford could also move that content if they wished. We also had a reverse process where we could see some of Salford's content and move that back to us if we needed to. In the center of that blue block is the Avid storage. So the way this was set up, we had the media grid, which we call the work in progress library, and we also had an ISIS. This ISIS held all the content for all the Avids. We had 21 edit desks plus 4 in use. They were all hanging off this ISIS. The content that resided on there, in theory, was meant to be transitory. Everything would land on the grid and stay there. Because of the size of the system and the fact that we had to support projects like the closing of the whole games, we needed to keep quite a lot of content current on the ISIS. It was sized sufficiently that we could do that and keep it all there for a very long time. So we had 128 usable terabytes of storage on the ISIS and over 200 terabytes on the grid. The media management process during the games was to delete content we no longer wanted and archive content that we did want. Now, sorry, my laptop keeps going funny. We would move that content onto a series of QNAP servers in CTA2. So anything that was required to be kept got moved onto a separate set of servers, 2 copies of it. One copy resided with us, the other copy would go to Salford. That was the original plan. However, we kept all copies till the very end. That meant that when this content migrated to Salford, they had a massive library, file-based, logged, all ready to go. And in fact, there's a DVD that came out just before Christmas that was edited from that content on those servers. So everything was kept together, and a very sort of quite slick DVD production resulted at the end of it all. But it now means the BBC's got all that content to use in its own library, as long as they have the rights for it. Moving further to the right on the diagram, we've got the transmission side of things. So we had effectively 4 EVS servers on the transmission side, plus a 5th one handling the 3D side of things. These servers literally supported the PCRs, as I said earlier. We also had some analysis operations going on as well. So we had Piero and Dartfish. So as a certain amount of stuff went through those systems to give a slightly enhanced view of the world. So you get a punter in the studio explaining how things worked from an athlete's perspective using that analysis software. And we also obviously had our links through to the sailing and into the BBC real estate and BBC desktops, which is how IP Browse worked. So moving on, that kind of puts it all into quite a big nutshell. I'm just going to canter through all this stuff now so we can get to the end for any Q&A. Ingest, some pictures just to whet your appetite. Doesn't look very interesting from here, but obviously there was a lot going on, as I've briefly outlined. We had an MFA area which also had decks and tape machines in there. We could burn DVDs if necessary. We tried to avoid it because obviously you could view stuff on IP Browse. The edit areas, the 2 areas I highlighted, so you've got the edit suite on the left and the edit desk on the right. So it gives you an idea of the sort of size and how many people we managed to ram in. I talked earlier on about the audio philosophy. This gives you an idea of what we did for the audio. So the top part of that diagram is the audio layout for if we were doing a project which went through an edit suite generally. all the audio was finished. The guys could monitor it properly. They were very happy with the finished product. That went to the transmission LSMs as a stereo pair. That meant, as it went out, the guys driving the sort of audio desks just put a one set of faders, and that was that. The philosophy for fast turnaround items was that we would keep things separate. We would keep our commentary and effects separate. So edit desks, we adopted a policy for the audio on the bottom part of that diagram. So you had the opportunity then to keep your commentary, which you edited, and your clean effects, which you edited, as separate elements. And that was sent to the transmission servers in that form. So if for any reason, and does quite often happen in sport, they decide you finished an item, it's gone, it's ready to be transmitted, the director in the gallery suddenly decides they're going to join it late. They don't want to see the first 2 minutes. They want to join it after the sort of third goal or something like that. This meant that the guys in sound could just fade up the clean effects track, and then at an appropriate point when they were doing a pre-hear on the commentary, they could hear there was a good in coming up, fade up the commentary, and it sounded and looked a lot smoother. It looked as if it was intended to be that way rather than being a bit of a cock-up. So that meant that we had to adopt two different philosophies as regard audio, which also meant that when we were doing sending our packages through to the transmission servers, we had to label them accordingly. We had quite a complicated labeling system that identified content as either being stereo or split, also identifying what channel it was meant to be transmitted on, as well as giving it a name. Now, we had to go for a series of letters and numbers because, as far as the LSM operator is concerned, they can only ever see 12 characters on their screen. If you're looking at the content on the system, on IP Browse or IP Director, you can see a vast string of characters, but the first 12 are the only ones that are visible to the LSM operator. So we ended up getting quite a complicated code. Once everyone understood it, it made life a lot easier. Transmission replay, as I've just been saying, difficult to see the scale of it all, but that kind of mess in the middle is 4 LSMs, 4 desks, lots of people. They could see, if you could see the monitors sort of near the ceiling of that picture, they could see the ingest channels as well. So everything being ingested, they could see what was coming into different ports of different servers. So if there was a shout from the transmission side of things that we need to get across the ... rather than shouting where the hell's the judo, they could quite often see the judo on the screen. They knew it was coming into ingest channel 12. They could use a separate network to access this content and play it to air if necessary. 3D. I'll skip very briefly over this. We basically had a simple operation. We monitored the 3D feeds coming in. We checked them, sort of did a QC check as much as possible, edited together the content we wanted. We had one 3D camera crew. They went out into the Olympic Park. They shot an opening link, sometimes a closing link. We basically played that all to air as a playlist from the LSM, bolted a front on it, bolted a back end on it, playlist of all the content in the middle. The front and the end were stereo. The middle bit, which was the highlights package, was 5.1. So it had to be run effectively as 2 elements out of the LSM. One lot of stereo, one lot is 5.1. So the guys in the gallery would mix the two together. The Cowan desk, which is where I spent my life, basically, I could see everything, I could hear everything, I could talk to everyone. Basically, that was it. It meant I could actually see what was going on. I could preempt any issues I saw them coming up, and I could communicate with the support guys who were literally just below that desk on another set desk. We could make sure we could monitor the system there. We could see what was going on, and we could effectively manage things very well and actually make sure that there was enough space on servers, enough space on the system, etc., etc. And also listening to the talkback from the various galleries, I could tell whether or not something was about to become a car crash because they were asking for something that either didn't exist, wasn't ready in time, or there were other issues we needed to deal with. CTA2, boring, but there you go. It's racks full of kit, but obviously a vital part of the operation. A huge amount of EVS kit in there. EVS was sort of the major partner in all of this, making it all work. Media grid for the storage, Avid kit for all the editing, etc. It was all joined together with a very large Cisco switch. In the past, we've done this by effectively having lots of different switches for each system and then joining them where we needed to. The philosophy this time around was we would have one very large switch with lots of VLANs. This would handle everything. Obviously, it was a single point of failure, but we did lots of tests. We're pretty confident that it would work all the way through, and it did. There was never any issues with the switch. And just to sort of end it all, I'll give you a little one more video just to see how we go. So, any questions? Resounding silence.
Yeah, I was just wondering how the OBS operates effectively during the fortnight, because if they go from, say, having 5 staff now to having 500 staff, during that time, it takes time for any freelancers or extra staff to gel and all this sort of thing. Do they work in conjunction with the BBC, or how does that work?
No, the BBC is as we're a rights holding broadcaster, you pay for everything you receive from OBS. So contractually, they have to provide it. So whether that be I want a circuit coming into my building like this, or I want to be able to get in access to one of your servers. I mean, we had access to the host server as well. I didn't mention that during this presentation, but we could see content on their system as well. But no, the way OBS works is, in the initial planning stages, it's a very small number of people. But at the beginning of the Olympic year, it slowly ramps up from being about 20 people to getting close to being like 5,000 people. So they take it on slowly, because the way OBS works is they just contract anyone they need to. So, for example, they contracted BBC staff. They weren't BBC while they were working for the OBS setup, but they were effectively BBC staff doing the whole of Wimbledon. So it was a SysOB with BBC staff. That was packaged up as the tennis feed from OBS, but they just contract who they need to make it work. So in advance of the games, they will sort of have contracts in place, do negotiations, work out what they need, which is one of the reasons why during the Olympic year, if you want to do any other event, you're probably slightly buggered, because all the kit, all the staff, everything's taken up. So that's sort of how it works.
And just a second quick question. Any edits done in the edit suites or on the edit desks? How is the process from taking the footage to them? I mean, is everything in a network, and they take the files that they need, and then they have the edit, and then it's available to anyone else in the village, in the building?
So we had various systems to help us there. So obviously the content would arrive on the media grid. Producers could look at content on IP Browse. They could send it to ISIS. As long as they called it something sensible, it could be found. If they called it My Thing 01, then it's probably not going to be found, or Russia's 01. But basically we had a sort of naming convention enforced that people were meant to call things the correct things, so it could be found on either system, either on the media grid or on the ISIS. Content would arrive there. The editors could pick it up. It was just straight away it was available. Stuff would be streamed in from the servers. So of the 32 feeds coming in, we could stream 12 of those directly to ISIS. So if it was a fast turnaround edit, the content as it landed on the server was available to edit. So we were only, say, 15 seconds behind real time in terms of people being able to edit stuff. Obviously, it takes some time to propagate all that content through, but it wasn't that desperate. We also had a system called Magma, which meant we could put graphics on. So once, in the same philosophy with the producer, be able to sit at a desktop and find stuff, send it to the ISIS, or send it to transmission. We also had a desktop application called Magma provided by Delta Tray, which meant they could create their own graphics. So rather than having the graphics guys sitting there constantly, we ring them up, I want a lower third saying, Sir Chris Hoy, please. You could just, using a templated system on a computer, it was on the BBC desktop, you could create your own graphics and send them to our specified area for post-production. We could import those graphics. They were all done in the same codec as we were using for the main media. Very quick to render, send them off to transmission. Anyone else? Great, I'll go to the bar. Thank you very much, everyone. Cheers.